So let's move on to Module 2. That's a section on statistics. Question 3, Part A. This seems to be permutations and combinations. A code breaker has been challenged to overcome a 6-element or 6-character password. The password is a combination of the points, inputs, characters, ASTUV, that's 5 letters, and 259, 3 numbers. So the password, so 8 characters. The password is a combination of the inputs. Okay, ASTUV, 259, without repetition. How many unique 6-element passwords can be generated using these inputs? Alright, so a number of unique 6-element passwords. Alright, how many of them? Alright, so the solution, we can get a solution. Okay, so the password should have 6 characters, 6 elements. Alright, so let me put just 1, 2, 3, 4, 5, 6. Alright, 6 of them, and it can be 6 from these 8 characters. Alright, so if you think about it, there are 8 characters, 8 distinct characters without repetition. So in the first slot, let me just erase this to avoid confusion. In the first slot, any of these 8 characters can be there. And if I put a character in the first position there, I'm left now with 7 options. So in the second slot, any of 7, I have 2 slots used now, so I'm left with 6 characters, and so on. Alright, if I have 3 characters, I'm left with 5 for the 4th, 4 for the 5th, and 3. Alright, so if I multiply these values, 8 times 6 times 7, 8 times 7 times 6 times 5 times 4 times 3, I'll end up with 20,160 different unique passwords. That's our solution. Another thing another way we could have found the solution is, if you remember, notice their passwords. So these characters, the order would matter. So we have 2 formulas for combination, NCR, NPR. So NCR is when the order does not matter, or the order does not matter. And NPR, the order matters. The order matters. So for example, if I should form a password, a 6-character password using these characters, that's 5, and let's say I put 2 beside it, so that's 6 characters. If I should turn it around and have 2VU TSA, that's that. So even though it's the same exact 6 characters, the order is arranged differently, so it's a different password. Because we all know from experiences, the order in which you put the characters would make it a different password. Alright, so a different order, different password. So when that's the situation, we use the formula NPR. And notice we have 8 characters, and for those 8 characters, we're picking 6 to form the password. So 8 pick 6, you can use a calculator, you should get 20,160. Or 8 pick 6 is the same thing as 8 factorial over 8 minus 6 factorial, the difference, which is 8 factorial divided by 2 factorial. And with your calculator, that should give you 20,160. Alright, whichever way should be okay. Next, part 2. How many, make sure we still look at the correct. So part 2, how many unique 6-element passwords can be generated if the code breaker knows that the password must begin and end with a number? So again, the password must have 6 characters. 1, 2, 3, 4, 5, 6. Now, if you notice the characters, the options, we are told that the password must begin and end with a number. So notice we have 3 numbers. So if I put a number in the first slot, I have 3 options. So any of these 3 could be put in the first slot. And if I put a number in the first slot, in the final slot, which should also have a number, I'll have just two options. Because if one number is here, then so in the first slot, any of the three numbers, 2, 5, or 9. And if any one of these 2, 5, for example, if 2 is here, then in the final slot, I have two options, 5 and 9. Or if I have 9 in the first slot, then in this final slot, other options will be 2 and 5. So the first slot, I have 3 options, and once I place a number there, the final slot, I only have 2 options now. So if you notice, so in the first slot and the final slot, 2 numbers will have been used up. So we are now left with 6 characters. So in the second slot, we can pick any of 6 characters. In the third slot, any of 5 characters. In the fourth slot, any of 4 characters. And notice, and in the final slot, any of 3 characters. Alright? So 3 times that. So multiply them, and we'll end up with 2,160 unique passwords if the password should begin and end with a number. So again, the explanation, the first slot and the last slot must end with a number. Notice we have 3 numbers. So in the first slot, we have 3 options. And once I put a number in the first slot, for the final slot, I would have 2 options because 2 numbers will remain. So 2 characters have been used out of the 8. So for the second slot, I'll have 6 options. And then for the third slot, 5 options, and so on. Part B, the data below summarizes the length of 31 carrots taken from a farmer's kitchen garden. So we have the table here, group data. Draw a histogram on the grid provided on page 15 to represent the data above using a 1-to-1, 1 centimeter to 1 unit on both axes. Alright, so I won't be drawing this histogram. So the histogram, just a reminder that the histogram you have to rewrite the intervals into boundaries. So you add 0.5 to the numbers on the right, take 0.5 to the numbers on the left. So add 0.5 to 3, you get 3.5. Take 0.5 from 1, you get 0.5, and so on. You do the same thing for all of them. And for the last one, add 0.5 to the 15, 15.5. Take 0.5 from the 13, 12.5. Alright, so, and that you do that for all of them. 3.5, 6.5, 6.5, 9.5. Second to last one will be 9.5 to 12.5. And you know the histogram, there are some bars and all the bars would be connected. Alright, so we'll draw that. Let me move on to part 2. The mean, the formula for mean. What's the formula? The formula for mean is equal to sum of fx over n. And where n is a number of, in this case, number of things, number of carrots. So in this case, n will be 31. Alright. Fx, so let's make space. So we need f. Notice the x, the length, is intervals. So to get the x, we simply average the intervals here, and we average them by just add them and divide by 2. So add the upper limit and the lower limit, divide by 2. So 1 and 3, 4, 4 divided by 2, 2. So this would be the x values when you're doing the calculation. 4 and 6, 10, divided by 2, 5. 7 and 9, 16 divided by 2, 8. That's 12, 22, that's 11, right? 13 and 15, 28 divided by 2, 14. So sum of fx, the frequency times the x, so 3 times 2, that's 6. 6 times 5, that's 30. 8 times 10, that's 80. 8 times 11, so the f value times the frequency, which is the f times the x value. 8 times 11, that's 88. And 4 times 14, that's 56. And I think these numbers add up to 260 and divide by 31, and I'm getting 8.39. So I mean, and the unit centimeters. So 8.39 centimeters. Let's continue. It was assumed that the length of the carrots, follows a normal distribution with mean as calculated before. So the mean and we use the symbol we use for mean is mu, 8.39, and variance 6.25. So if variance is 6.25, the standard deviation is the square root of the variance. So the standard deviation will be the square root of 6.25, which is 2.5. So remember, standard deviation is square root of variance. So square root of 6.25 is 2.5. Calculate the probability that the length fall between 12 and 6 centimeters, giving your answer to 2 decimal places. So the probability that the length, so I'm just call let length be x, use this. So let the length be x. So when the probability that x is between 12 and 6 centimeters. So we need to find the z values. Let's find the z values now. The formula for z. The formula for z is, so z is x minus mu, understand the formula sheet, over the standard deviation, sigma. So let's do z1. And I'm going to do the z value for the upper one, which is 12. I'll call it z1. Alright, so when x is 12, minus the mean, mu, the mean, which is 8.39, divided by standard deviation, square root of the variance 6.25, we found that to be 2.5. So Z1, 12 minus 8.39 divided by 2.5, I'm getting, use 2 decimal places, 1.44. And then Z2, let me do Z2 up here. So this is Z1. So then I find a probability that Z fall between. So when the x value is 12, standardized value Z value is 1.44. And when x is 6, let me find the Z value for when x is 6. So for when x is 6, the Z value, I'm going to call it Z2, will be same form x bar. So I'm using 6 now. Same mean of 8.39. Same standard deviation of 2.5. So Z2, I wrote that out. I'm getting negative 0.96. So when the x value is 6, the z value is negative 0.96. So we standardize the values. For 12, z value is 1.44. For 6, z value is negative 0.96. And we can use the table. Or simply use the table. For the table, we look for probability z is less than 1.44. And the table should give us 0.9251 minus, I'll look for when the z value is less than 0.96, and when it's less than 0.96, negative 0.96, sorry, the z value is, the probability is minus, well, is 0.1685. So for 1.44 in the table, when the z is 1.44, the probability is 0.9251. For the corresponding negative 0.96 in the table, the z value is 0.685. So it's between, so we take a difference. And we end up with 0.7566 as a solution. To find a negative 0.96 using a table, is one thing you could do is find the 0.96 for the z, get the probability, and then subtract it from 1. And you'll end up with 0.1685. So I could use a positive z value and subtract it from 1, you'll end up with 0.1685. Alright, so that's that. That's a graph for the histogram. On part D. So part D, a manufacturing company provided one of its customers with data on the number of units it would be willing to sell at each price level. This data can be used to estimate the equation of a supply line, and its equation should be in the form y equal a plus bx, and we're given the summation, so they save us some right there. Alright, so we're given the summations for each column if we should create a x and y, x square, y square, y, xy. Alright, so using least squares regression estimation, calculate the values of a and b. So the formula I have for a and b, so the formula I have for b is, where is it? The formula I have for b is that b is equal to the sum, b is equal to SSXY divided by SSX. Now SSXY, the formula I have for that is the sum of xy minus sum of x times sum of y over n, all over sum all over SSX, and SSX is the sum of x square minus sum of x all square over n. Let's make the substitutions now. And n is just a number of pairs. So notice we have, I'm going to count on our x values. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 pair of values, so n would be 9. Alright, let me make our substitutions now. So sum of xy, we have that. Sum of xy, that's 916, 425. 916, 425. Sum of x is 5633. So 5633 times sum of y, that's 1455 over n, which is 9. So all of that over the denominator now, sum of x squared, that's 3,527,093 minus sum of x all square, so sum of x, that's 5633 all square over n, which is 9. So those are the substitution. Alright, so using your calculator. Alright, the numerator should work out to be what now? The numerator should work out to be I'm getting 5756.667, and the denominator, so this is what we have, this is the numerator, all of this, and the denominator is all of this bracket, and I'm getting 1460.889, and the final value for b $3.94. So the final value for b is 3.94. That's the value for b. And then now let's find the value for a. And the value for a, let me do the value for a here. Now the value for a now, let me, I'm out of space, let me do it here. The value for a, the formula for a is y bar, and y bar just simply means y average, minus b times x bar. So notice to get a, you need b. So the formula for a, so is y bar, and how do y now? Y bar is y average. So y bar is just y total. The sum of the y bar is y average, so it's the sum of all the y values divided by n. So now the sum of all the y values is 1455. Alright, so y bar is that divided by n, which is 9. So that's 1455 divided by 9. So it's average of all the y values. Alright, minus b, now b is 3.94 times x bar, and x bar is x bar is same as x average, so it's the sum of all the x values. The sum of all the x values, which is sum of x, 5,633 divided by 9, so x average, sum of x divided by n, so 5633, alright? So x bar is 5633 divided by 9, alright? So just a reminder, y bar is sum of the y values over n, and x bar is the sum of the x values over n. Alright, so following up with that, so A, I do the calculation there, so A, I'm getting for A, that's now 2,304.3. I guess, depending on the amount of decimal places you use in your calculation, you will get certain variation. But it's 2,304 point something should be there about. Now the equation for the supply line, so the equation, remember the equation is y equal a plus bx. So the equation is y equal to a plus bx. So is y equal to a value. So the equation is, answering part 2, just to answer part 2, the equation is y equal to a, which is 2,304.3 plus bx, and b, here's the b value, 3.94 times x, alright? So the formula is y equal a plus bx. So we found a, we found b, we just plug them into, just replace them, and we end up with this as our solution. So this is our solution, alright? 2,304.3 plus 3.94x, and then the amount of decimal places will determine, how far you vary, depending on how many you use. Alright, let's move on. Alright, so we're at question 4. A die and a coin are thrown one after the other in that order. While the die is fair, the coin is biased with the probability of attaining a head. So the coin, the probability of obtaining a head is 2/3. So it's a biased coin. So normally a fair coin, head would be a half, tail would be a half. But this coin, the probability of observing head is 2/3, which means the probability of observing a tail is 1 minus 2/3, which is 1/3. Alright, so notice when you add both probabilities for head and tail, it should add to 1. So if head is 2/3 and tail is 1/3. Now let's look at part 1 now. The die is fair, so any number on the die would be 1/6. Alright, determine the probability that the coin shows tails given that the die showed an even result. So it's a conditional probability. So the die was tossed, and then the coin was tossed. So we have to check if the events are independent, which they are, because what will show on the coin has nothing to do with what shows on the dice. Alright? The number showing on the dice has nothing to do with what's showing on the coin. So the probability of observing tails, the probability of tails, I'm using t for tails, should be 1/3. Alright? Same as 1/3. Because the head is, if you think about it, the head is 2/3. So the probability of observing tail would be 1 minus 2/3, which is 1/3. Alright, notice both head and tail must add to give 1. Alright, part 2, determine the probability that the die shows an even result and the coin shows tail. So the die, remember the die has 6 faces, 1 to 6. And how many of these faces are even? So 2 is an even number, 4 is an even number, 6 is an even number. So the probability of showing an even number, so the probability, let me use E for even. The probability of showing an even number is 3 options out of a total of 6. Alright, which is the same as a half. And we already found that the probability of tails, we just found the probability of tails to be 1/3. So the probability that the die show an even number, and I use the intersection sign for and, it shows tails. Since the events are independent, it's probability of even number times the probability of tails, which is probability that even is a half, because 3 even number out of 6 possibilities. Probability of showing tails is 1/3 So half times 1/3, that's 1/6. Part B, in question 4. It is known that 40% of students at a large school live in poverty. In a sample of 10 randomly chosen students, calculate a probability that exactly 2 students live in poverty. So we have to first determine what type of distribution is this. So this is obviously a binomial. We've got 2 options: either the students are in poverty or they are not. So a binomial with a probability P is 40% and 40 over 100, that's 0.4. Well, I put the n value first, alright? The number of trials, in this case, number of persons in the sample, that's 10. And the probability of success, which is, in this case, those who live in poverty, would be 40 over 100, that's 0.4. And of course, we can let x be, let x be students in poverty. Students living in poverty, alright? So in part 1, we also calculate the probability that exactly 2 students live in poverty. So I use the formula, the probability x equal k, or some form x equal r, whatever. So it's n c k, that's the formula, p to this to k, bracket 1 minus p to the power n minus k. So using this, n is 10, exactly 2, so choose 2. P is 0.4, 40%, so 0.4 to the power of number down below here is 2. And in the second bracket, we'll have 1 minus p. So in the second bracket, notice p is 0.4. So the second bracket, 1 minus 0.4. So the second bracket should be 0.6. Notice the 2 brackets always had to give 1 when you're using the binomial formula. And in this, and the power here is n minus k. So these numbers, 10 minus 2, which is 8. So we can use our calculator for that, or the tables, and we should get, we're using, so 0.302 or 1199, something like that. Alright, part 2, the probability that at least 3 students live in poverty. So at least 3, remember x represents those who live in poverty. So at least 3 means 3 or more. So we want to find the probability that x is greater than or equal to 3, which is the same thing as, so greater than or equal to 3 would be from 3 to 10. But we can also switch it around and say this is 1 minus probability. I'll change this around, x are equal to, so is less than 3. Alright, so less than 3, we can find it, less than 3 would be, for what now? Probability, less than 3 would be, what are the numbers which are less than 3? 0, plus 0, 1, and 2. So to find for those less than 3, we should find for x equal 0, x equal 1, x equal 2. Those are the numbers below 3. So it will become 1 minus, using the same formula, NCK formula there, for, so NC, so n is still 10, so 10, so 10 for 0, so 10, choose 0. P is still 0.4, so 0.4 to the power 0. And then in the second bracket is 1 minus p, so 1 minus 0.4, that's 0.6 to the power of 10 take away 0, which is 10, plus the probability x equal to 1, so this time it's 10, choose 1, 0.4 to the power 1, 0.6 to the power of 10 minus 1, which is 9, plus, and probably x equal to, we found that already. The probability x equal to 2. The probability x equal to 2, we had found already, which is 0.02, right? So this was 0.02. Alright, so this is equal to 1 minus, so let's work out this one. We end up with this now, 0.10737 plus this one, 0.26844, and we had already found this to 0.02. Maybe I should have used more decimal places, but anyhow. And then all of this, the final answer, well, this is 1 minus everything in the bracket, should be 0.6778 or something, or thereabout. So the final answer should be 0.322. Let's move on. A principal intends to gather information about students' performance in math. A statistician suggested to her that either a sample survey of a population or a population census could be conducted. Distinguish clearly between a sample survey and a population census. So a population census, in the context of this situation here, the principal wants to collect data about math performance in the school. So the population would be the entire school. Alright, in this case, the population would be the entire school. A census in the entire school. And the sample, the other sample, would be a subset of the school. So a sample could be a class or a grade level or whatever. Some will be a subset of a school, depends on how they want to take it, alright? State a limitation of conducted a population census. So, I mean, there are many. One limitation, there could be privacy concerns. Maybe students don't want to answer certain questions they might probably deem too personal. So, of course, students maybe put inaccurate information, inaccurate info. And then it probably just impractical based on the amount. So impractical, so maybe there will be time constraints, time limit, and so on. Many examples of maybe limitations, alright, or disadvantages. The principal plans to build a sample of 100 students using either systematic random sampling or stratified random sampling. Distinguish clearly between systematic and stratified sampling. Alright? So, let me deal with stratified first. So, the stratified sampling is that students are divided. So, students can be divided into subgroups or stratas, into subgroups. Or what we call strata. And this could be, and for example, so this could be in terms of like their age, grade level, or where they reside, place of residence, alright? Could be in terms of the geographical location. Good? Geographical location. And then now, a random sample is selected from each group. So it's then the random sample, after dividing the students into subgroups, then random sample is selected from each strata. Random sample selected from each of the subgroups or strata, we call it, right? So let me give an example. So let's say you want a sample of 10 students, right? Well, 100 students. So, you know, let's say there's a grade 7. Let's say you have grade 7. You have grade 7 students, grade 8, grade 9, grade 10, grade 11 students. So what they could, the teacher could do is, okay, divide the students, so 7 groups. So from grade 7, they select 20. From grade 8, they select 20 randomly. From grade 9, they select 20. Grade 10, 20. Grade 11, 20. And that will get the 100 students. So that way they have a representation from all grade levels. 20 from each grade level. That will give you 100 students. That would be an example of stratified sample. Alright? The other one is systematic. So systematic, so students can be, say, divided into what you call alphabetical order. Let's say, systematic. So systematic sampling, let me just erase this. So systematic sampling, what could be done is that the population is ordered. So you number the students. So you give each student a number, each student in school a number. So students are ordered, so students are numbered. Or you could put students in alphabetical order. Let me say students are numbered. So give each student a number, and you could say, okay, we're going to select every 5th student. So you count, line up the students. So you say 1, 2, 3, 4, 5, you choose that student. 1, 2, 3, 4, 5, you choose a 10th student. Alright, so every 5 you choose a student. So after 5, you count to 5, you choose the student at 5th, you choose the student at 10 to be a second student, the student at 15 to be and so on, and so on, and so on. Alright, the student at 20 to be the 4th student, and so on. Alright, so that's an example of systematic. Alright? Alright, let's move on. Let x be a random variable which records the number of blighted trees in a randomly selected park. The table below shows the probability distribution for x. Calculate probability distribution, calculate the expected number of blighted trees. So the formula for expected value, so E of x is a summation of x times the probability of x equal x. So in this case, let's do the calculations. So multiply each of x value times the probability and add. So 1 times 6 over 27, that's 6 over 27. 2 times 5 over 27, that's 10 over 27. 4 times 3 over 27, that's 12 over 27. 5 times 8, that's 40 over 27. And 6 times 5, that's 30 over 27. So you multiply the x value times the probability and you add, you sum it up everything. And if you add up, notice we have a common denominator. We have 27. So if we add all of these values, we'll get 98 over 27. In decimals, that's 3.63. If I'm using 2 decimal places. Alright, part B was to find the standard deviation. Now, the standard deviation so it refers you to find the variance first, alright? So let me put the formula for variance. So the formula for variance of x, so the variance of x is equal to sum of, so expected value of x squared minus e of x all square. E of x all square. So e of x squared minus e of x all square. So let's find e of x squared now. So to find e of x squared, let's find e of x squared. To find e of x squared, now notice how we found e of x. E of x is x times the probabilities. E of x squared is x squared times the probabilities minus e of x all square, and we found e of x was 3.63. So e of x all square is 3.63 all square. Alright, let's find e of x square now, and again e of x square is x squared times the probabilities. So let's go back up. If you notice, here are the x values. Let's find the x squared values now. So x squared, I'll create another row. So x squared, square 1, I get 1 square 2, 4 square 4, 16, square 5, 25, square 6, 36. Alright? So e of x squared is x squared times that. Let me work out e of x squared up here. Let me work out e of x squared. Where can I put it? Let me work out e of x squared up here. So e of x squared. So x squared times the probability. So 1 times 6 over 27. That's 6 over 27. Plus 4 times 5. That's 20 over 27. So this time I multiply. So e of x, we'll use the x values. E of x squared, we use the x squared values. So 16 times 3 over 27. That's 48 over 27. Plus 25 times 8 over 27. That's 25 times 8. 200. And then 36 times 5 over 37. So 36 times 5, that's 180. So if I add all the numerators, I end up with 6 plus 20 plus 48 plus 200 plus 180. I'm getting 454 over 27, which is equal to 16.81. If I'm using 2 decimal places, 16.81. So e of x squared is 16.81. So come back to here. Variance of x is e of x squared, which is x squared times that. We found it to be 16.81 minus 3.63 all square. That's 13.18. So this is 16 point minus 13.18. I'm getting 3.63. So that's a variance. So the question asks for the standard deviation. Alright, so a standard deviation. Let's write SD for standard deviation. It's the square root of the variance. So it's square root of 3.63. Whatever that work out to be. Should be 1 point something. Let's move on to question 5. That's a calculus section.